I want to try combining the outputs of the wind farm VOTs into to one signal and then drive two cob LEDs in series. The rated voltage of these are they're 12 volts, and then if I put them in series that would be 24 volts. My wind turbines are designed to go drive a load of 16 volts, which is going to be a little bit low. So I thought what I'd do is I'd take a boost converter and combine run the outputs of the turbines into this and then boost it up to the voltage needed for the cob LEDs. But I've tried something similar to that before, and what ends up happening is it just sucks so much current out of the turbines that it starts running off the low voltage cutoff of the chip. And I believe this one has a low voltage cutoff of about 5 volts. And that's a much lower voltage than what they're designed for. They're designed to drive a 16 volt load. So that's not going to do. I don't want them to drive such a low voltage. So I'm going to modify this board and add some additional electronics to try to make it work well. I think this is the problem. Normally what we have with the boost converters, we have essentially an infinite supply of power on the input side and a limited amount of loading capacity on the output. And so what we do is we limit the voltage coming off the boost converter so that it can drive the load to a particular voltage. So we take a feedback circuit and so we drop the voltage a little bit, and then we feed back that voltage signal. And if the voltage gets too high, then we start cutting off the current going through the boost converter. And the boards that I have, they had a 10K pot and then a 270 ohm resistor, and so you'd adjust this pot to whatever voltage that you wanted, and you get 1.25 volts here, and anything above there would start cutting off current. Anything below would allow more current to flow through. But with a wind turbine, we've got a limited supply, and the LEDs in this case can probably take anything that the wind turbines can supply. So what I have to do is I have to limit the voltage on the input side so that I don't pull so much current that the voltage drops too low. So what I'm going to do is I'm going to have feedback from the input side. The problem is the logic is wrong, because when this voltage gets too low, I want to start cutting off the current flow. So when this is low, but in this case, if this was low, it increases the current. But in this case, when this is low, I want to decrease the current. So I need some circuitry between this signal and the feedback pin to essentially invert that. So when this gets low, I want to cut off current. When this gets too high, I want to increase current. So this is the circuit I'm going to be using. Just a few things here. I've got the voltage input here. I'm going to use the input voltage to supply power to an operational amplifier. So I've got a little voltage regulator here that takes the input voltage, keeps it at 3.3 volts. That's what I'm using for my supply. Then I've got my feedback resistors, a 34K and a 3.3K, and that should provide 1.25 volts here when this voltage is 14 volts. So I'm figuring 14 volts, a couple volts for diode drops in the rectifier, and then that gives me my loading on the turbine. So the amplifier has two circuits here. The first one I'm just using as a voltage follower so that we've got a low impedance source here. The second one, I take the 3.3 volts, divide it down, so I've got 1.25 volts, as a reference, then I take this low impedance circuit or output here, feed it in two identical resistors for unity gain, and then I put that in as the negative input for the second amplifier. So that way, when this voltage goes up, it's going to affect this output and make it go down. So it's inverting the action here. And then this is going to go to the feedback pin. So here's the actual circuit board that I've got. We've got the input here. I don't know if you can see it, there's a voltage, that's the voltage regulator right by my thumb here. There's the amplifier, got some filter caps and the resistor network. But what I'm going to do is I'm going to put the wires from the wind turbines in here, and then I've got some mounting points for the V in and the V out, so I can put the LED load on this side. Then I took one of these boost circuits and I took off the potentiometer that was here and that 270 ohm resistor. And this will give me access to the feedback pin of this chip. So there's this, the center pin from the potentiometer is connected to this feedback pin. So I'm going to connect that. It'll be mounted like this. So I've got a hole for a post here, and then I've got holes for posts on the input and the output. And so I can just put this boost circuit on top, and that should complete things. Okay, here I have the power supply, and it's just feeding the board. I don't have the boost converter on top of it. And I'm going to be monitoring the feedback here. Okay, so that's the voltage that's going to be fed to our feedback on the boost converter. Okay, so here's my voltage, and you'll see if I go down, then we have an increasing voltage on our feedback, which would turn off the boost converter, which is what we want because we don't want it to get too low. And as I increase the voltage, you can see that the voltage goes down. So when the voltage is higher than 14, oops, get that back in there, then our feedback is below 1.25, and that would turn on the boost converter. It'd start calling for more current. So as I reduce this, get to about 14 volts, we're at 1.22 or 2.3, gets below 14 volts a little bit. And it's off by a couple tenths, it's not a big deal. So we're at 13.7 and we're above 1.25 volts, and so the boost converter would turn off. So here's the finished board. The modified boost circuit has been stacked right on top with some posts, and I can just feed wires in here and feed wires out there. That'll connect up the boost, and we've got the feedback. So we'll see how it goes. Okay, I've got my LEDs wired in series, so the goes in the positive, the negative of this is connected to the positive of this one, and then it goes to the negative, and that's coming off the boost converter. And then I've got my power supply coming in, but in this case I've got it current limited, so it's only going to be able to put out, I don't know, about 30 milliamps or so. And the idea is to, see if I can get that in the picture there. Back up a little bit. Okay. The idea is that it will turn on when the voltage gets above a certain level. So here's 13.4, and here at 13.5 it's starting to turn on, and it flickers a little bit. But this will not go above that voltage. I can keep trying to go up, but it's holding it to 13.5 because it's current limiting right now. It's not voltage limiting. So it appears to be working. I decided to go with 3 LEDs in series. Just I think it'll be able to handle the power a little bit better. So I've got the boost circuit going to the 3 LEDs. These will light at about 8 volts, so minimum of 24 volts to get lighting, but it's rated for 12 volts, so it should go up to 36 volts without any problem. And I've got the wind turbine on the input, and if this is turning slowly, the voltage doesn't get high enough to, well, there it did. It doesn't really get high enough to light the LEDs, but if it gets a little bit faster, then it does boost it. So I think it's working. So we can go slow and nothing. But as soon as it gets high enough to get above, like I think it was 13.5 volts, then it starts to boost.